Part 2 of your Scientific Notation Study Guide. Write your answers in standard form. For number 12 and 13, write your answers in standard form. So let me make this a little bigger here. Okay, to do this, you're going to take the coefficient right here and write that down. And then you're going to move the decimal the number of powers that are indicated. So this is 6 to the 10th power. So that decimal will get moved 6 places to make a bigger number. 1, 2, 3, 4, 5, 6. So now the decimal's in the back, and fill in with zeros. And then rewrite this so it looks neater. So this is going to be 5, 6, 1, 7, and we added 3 zeros. And now the decimal's at the back. You could also put in your commas to make this look more official. So this number, 5.617 times 10 to the 6th, is now 5,617,000. Okay, number 13, we're going to put this into standard form. So I'm looking here and the exponent is negative, so that indicates a small number. So we're going to put our coefficient down and put your pencil on the decimal. And we're going to go back 2 places. So 1, 2, and a lot of students will forget to write the decimal out front. Fill in with zeros. So let's rewrite this. So it's 0.0983. So again, make sure that you moved the decimal. So now it is out here. Now we're on to some operations with scientific notation. So we have to read carefully to decide if we're going to add, subtract, multiply, or divide. The weight of mercury is 6.975 times 10 to the 15th kilograms, and the weight of Mars is 5.714 times 10 to the 15th. What is the combined weight of both Mercury and Mars? So we're going to combine the weights. So that means this is an addition problem. If we're adding and the powers of 10 are the same, that means it's ready to be added. We can just add the numbers that are up front, or the coefficients. So it looks like this. We take 6.975 and 5.714 and add those together. The decimal should be lined up. So we get 9, 8, 16, carry the 1, 11, and 12. And the decimal's right here. And then we keep times 10 to the 15th. Now, there's a problem right here. Our front number has to be between 1 and 10. We're at 12, so it's too big. To adjust this, we move the decimal back 1 and add 1. So our official answer is 1.2689 times 10 to the 16th power. Now, you can use your calculator, and remember we've talked about putting our calculator in the science mode, second function, and look for the science English button, and put your calculator in that mode just to double check. Number 15, honestly, I had to read this a couple of times to visualize it, understand what was happening, and to figure out what operation this was. So I came up with the idea to draw a picture. So first we have planet Purog, and planet Purog, I'll just put a P in there, is 9.99 times 10 to the 5th kilometers away from planet Crete. So that's the distance between them. Planet Cicerob, so planet C, is 4.23 times 10 to the 5th kilometers away from planet Yvel. So I'll put a Y in there. So that's the distance between those planets. How much farther away is planet Purog from Crude? How much farther away is this distance compared to Cicerab and Yvel? This. So how much further is this distance compared to this? So what do you think there? What are we going to do with those distances? We're going to subtract them. So when we add or subtract, if our powers of 10 are the same, we can just handle the numbers out front, the coefficients, and line up the decimal. So I'm lining up the decimals and subtracting. 6, 7, bring down the decimal, and 5. So we get 5.67, and then we keep 10 to the 5th power. Okay, and again, I keep saying, punch it in. Check out the calculator option to make sure that you're computing correctly. When you do use the calculator to do this problem, be sure to use the grouping symbols, use the parentheses for each quantity as you type it in. An apple has 9.5 times 10 to the first calories, and an orange has 4.5 times 10 to the first calories. How many times greater is the amount of calories? How many times greater is the amount of calories in the apple compared to an orange? So we're going to compare an apple to an orange. How many times greater? That indicates that this is a division problem. So 9.51 times 10 to the first and 4.5 times 10 to the first. And when we divide, we can use our exponent properties. Okay, so we can do regular division with our coefficients. 9.5 divided by 4.5. So I'm going to put that in my calc. And that is approximately 2 or 2.1, and that 1's going to keep going. So we can just put a repeating symbol there. And then we keep, when it's a subtraction problem and the bases are the same, we keep the base and subtract the exponents. Now 10 to the 0 power, or anything to the 0 power, is 1. So this is just 2.1 repeating, or about, the apple is about 2 times greater. So you could put this in standard form, put these in standard form and divide them if you wanted. You could use your calculator and make sure you put your parentheses, use your grouping symbols. But you should get the same answer each time you do it. 2.1 repeating, or 2 times greater. The apple is 2 times greater than the orange in calories. Okay, the final problem. Question 17. Plankton are microscopic organisms that drift in water. I'm sure you've heard of plankton before. A whale feeds by swimming through masses of plankton with its mouth open. A single whale can eat, oh my goodness, 1,277,500 kilograms of plankton each year. Invertebrates eat, oh boy, there's a big number, that many milligrams of plankton each year. So it looks like this is going to be a complex problem, but all you have to do is put both of these amounts into scientific notation. So let's take a look here. So this number here, remember where we're going to put the decimal, right between the front two numbers. So this becomes 1.2775 times 10. Then to get the exponent, we go from the back where the invisible decimal is to where we put the new decimal. 1, 2, 3, 4, 5, 6 moves. So it's 10 to the 6th power. And that's kilograms. Then we put our other number into scientific notation. And there it is. Oh, man, this has a lot of zeros. Okay, sorry about all the moving around. Okay, the decimal here, we put it right between the front two digits. So we go 3.521 times 10. And again, the invisible decimal's in the back, and we moved it all the way behind the 3. So count the positions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our exponent is 12, and this one was milligrams. So I think we are done. So check your paper, check your study guide. Now be sure to study the entire study guide so you are ready for the test.